discuss two problem, so which is medium problem. So here, which is similar to the two sum one problem. So the only thing is the whatever the input array which is in sorted non-decreasing order, and also here they will be given target. So we should find two elements such that like summation of that is equals to target. So that is the problem. So like let us understand with this. So the 2 plus 7 which is equals to 9. So that's the reason they will be returning 1 and 2 as an index. But this is not 0 based index. This is 1 based index. So in this case 2, 3, 4, where 2 and 4 summation of 2 and 4 is equals to 6. So that's the reason they are returning out 1 and 3. So here to achieve this, actually there are many solutions. But we wanted to do the best solution possible, even in terms of space complexity as well as in terms of time complexity. So let us follow the first approach that we call it as a brute force. So where each individual element will be compared with other element uh, within a loop actually. Then calculating a summation of that, and if that matches with the target, so it will return the indexes. So which is similar to, suppose there are like four elements within an array. So this is ith index, and let us consider this is an jth index. So we'll compare the summation of this both. If both these are equal to the target, so it will return I and j. If not, the j will increment. So we'll do I and j summation. Again, if it is not matching, it will increment jth index. So after doing all the elements comparison for the I, so if it not found, so the I will be incremented to a next element. So again the jth element will be the third element. So we'll do a summation of these two. If again these are not matching, the jth will be incremented. So similar fashion, it will do the loop, inside loop. So this time complexity is big O of n square. The space complexity is constant. So and we are not satisfied with the time complexity what we have got here. So that's the reason we'll explore one more solution, which is ash based solution. So generally what we do is, so we'll introduce one ash map which will store all the elements here, and then we'll compare whether the elements with when we see the elements, we'll compare with the hash map. If we get any proper elements, then we'll return the indexes. So let us explore what is the hash map method is. Before that, let me explain one more concept. So suppose you wanted a plus b equals to sum or target. Let's say if this is the equation. So if I have any of my one of the operand, and if I have any of the target, if I have the target, so we can get another operand, right? So by doing a subtraction with the target and one of the operand, so we can get the another operand. So in ashmap actually what we store is, so one is the value and the index. So the value will be the array index value, and this index is the index. So once we know this, so our approach is similar. So let us assume there are like four elements. So when we see the first element, so what we do is, so we see the target minus of this value, of this value. So the summation of this, if it is found in our hash map key, so then the index, whatever the index is there, we'll get it and we'll return that index, this index as well as the hash map index. As because this is not possible because this is the first element, so there will be hash map will be empty. So we'll increment to a second index. In the second index, same thing, the target minus second index value. So this is we'll find it in our hash map key. If it is available, so we'll get the index of that, and then it will return the second index and the hash map index as an array. So this is the space complexity is big of n, because we can there's a possibility of storing all the elements of array in the hash map. And the time complexity is big of n, because in our case we need to traverse all the array elements. So here we can do better in space complexity. So that's the reason we'll go through the third solution, which is two pointer solution. Two pointer solution. So in a two pointer solution, we'll keep two pointers. One is at zeroth index, and we'll keep another pointer in a last index, which is n minus 1, where n is the length of the array. So what we do is, all as we know, it's already sorted. So there are like four elements, let's suppose. So this is A and this is B. So summation of these two, if it is equal to target, then we'll return these two index. If not, we'll compare with the target. So what if summation of these two, if it is greater than target, then the sum value is more than this target, which means so we should decrease we should decrease the summation. So to do that, so as we know that this b value, whatever the b value is, the more value, so that's the reason we'll decrement this. So we'll make the b as this, and again we'll do a plus b. So if suppose now, if the summation of this value, if it is less than target, then what we do is we'll increment the a value, because we know that this is a small value, this is a large value, and this is a small value. So this time we'll increment to this. So and then a plus b. So till uh, what point we'll do increment and decrement is, so any of these two pointers should not cross each other. So that is a should be less than b, or any of the pointer that is left or right pointer should not be crossing any of these pointers. So let us go deep into code and then we'll understand more. Okay, let's see the code. This is standard code. So where if the number array is null, so we'll return the empty index. So as I said, we'll keep two pointers, left and right. So left is the 0th index and the right is the n minus 1 index with number of length. And we'll be iterating, as I said, till the point where left is less than right, and we'll get the value of left and right index, and we'll compare whether this is equals to target or not. If it is equals to target and we have found the two sum, so that, and we'll return the index. This is as it this index is not zero based, so we'll add the one value. And if suppose if the value is more, so we'll decrement that right index. If the value is less, we'll increment the left value.